Kelly strategy is widely used for investment, especially if you know Warren Buffett, right? They have advice for investment. Kelly strategy is one way to invest the futures or some other stuff. So we're going to talk about the Kelly strategy. But this is a special condition of Kelly strategy, which is you bet $1, you get $1 back, right? But many times you bet $1, you got P dollars back, or B dollars back. That's a return. It's not a one-on-one. Okay, so then what do we do? Yeah, read this one first. Done? Time is up. So now let's have a look at the Kelly strategy. So this is the one. So this is gambling. No? Where's the other one? So this is a gambler. Wins or loses his bet with probability P1 minus P. Okay, independent of earlier games. So independent. When P greater than 1/2, the popular gambling system known as Kelly strategy is to always bet fraction 2P minus 1 of the current fortune. So today I'm going to discuss why 2P minus 1. Okay. So we calculated the expected reward last time. But let's see, in general. So Kelly is actually from the name John Kelly. The Kelly strategy is named after him. And he's a scientist from AT&T. AT&T in 1956. There is a lab called Bell Labs. Back then, in 1956 to 1990 or 2000, Bell Labs and actually have a great group of scientists. Okay, they're leading the technology innovations. So John Kelly is one of them. And they are studying the investment strategy. So this is if invest $1, okay, there is a probability winning to be P and lose to be 1 minus P. But if you win, you are going to get B dollar payback. And if you lose, then just lose $1. Because you just lose what you have bet. Okay? So now we need to determine something called intertemporal portfolio size. You know, when you are investing in stocks or futures, you have portfolio size depending on the return you have. Okay? So how to determine the interportfolio size? This is also called the Kelly bed size. Okay, and the optimal solution is actually based on the current money you have. It's actually the ratio you are going to invest PB minus 1 minus P divided by B. Okay. Now in the previous case, you see if B equals to 1, so what we have is F is actually equals to 2P minus 1. This is a ratio. Okay. Okay. Now suppose we get started from the fund A0. Now we're going to invest n times, and we are interested at AN. What will be the money we get? Okay, but in each investment, we're going to determine what ratio should we, based on current money, current fund that we have. What ratio we should do the investment. And now we have in each investment we have win and lose probability. So what is the probability of win that is in the k plus 1 iteration is actually equals to AK 1 plus BF, right? So why 1 plus BF? Because AK is the current money you have, B is the payback, but how much did you invest is AK times F. This is a Kelly strategy, invest the ratio, right, of current fund you have. This is AKF. Okay, so if you win, you got this amount of money back in the next iteration. Okay, what if lose? Lose AK plus 1 equals to AK, and then this is 1 minus F. Agree? Because you invest AK times F, and then you just use AK minus what you have in one iteration. Is this one clear? Okay. Now we tried n times, so we will have MP wins, okay, and N1 minus P loses. Okay, so what is AN? AN will become A0 1 plus BF MP 1 minus F and 1 minus P. Okay, agree? Because you tried n times, and on average you are going to have MP wins and M1 minus P loses. Agree? Because each try you only have two possibilities. So let's move this A0 to this side. This will become AN over A0, and then let's take square root of n. So this will equals to 1 plus BF P 1 minus F 1 minus P. Agree? This is what we got. But we want to maximize our return on AN. So what do we do? We want to find the F star that maximize this AN. What do we do here? Yes, yes, yes. So let's make this one, maybe we call it a capital F function. Now let's take, what do we do first? We take a log first, right? So that we can take the P, take the B down, right, from the power. So let's take log F, which equals to P log 1 plus BF plus 1 minus P log 1 minus F. Okay. Now let's take the derivatives. F with respect to F. And this will become PB1 plus BF. Agree? Because you have a coefficient B, you need to take it out. And then you put the 1 plus BF into the denominator. You have B on the top. And then this plus 1 minus BP, and but this coefficient is minus 1. So you just put minus 1 over here, then divide by 1 minus F. And you make this equals to 0. And later, if you solve this one is actually equals to F equals to PB minus 1 minus P over B. You solve it. This is the solution. So this is called, so I want to just give you guys a little bit more introduction on the where is it from and who is the name after, right? This is a little bit history about John Kelly and how he come out with this ratio, this size, this batch size.